Hello everyone, welcome back to our lesson video of programming with C++. At the end of this video, we are going to understand what classes are and why they are important. We also learn about the access control, that's the public, private, and the protected. We also master constructors and destructors who work with members, function, and attributes, and understand status members and memory allocations. So when you say classes, what are they? What are classes? So a class is like a blueprint or a template that you create to make objects. It's like a cookie cutter. The cookie cutter is the class, and each cookie you make is an object. More technically, a class is a user-defined data type that works as an object constructor. It's your way of creating custom data types that can hold both data and functions together. Inside a class, we have two main attributes. We have the two main components in the class. We have the attributes and the methods. So the attributes are like variables that stores data, and members are like functions that can manipulate that data. We often call these class members because they belong to the class. So the class definition begins with the keyword class followed by the class name. We start with the keyword class here. We give it a name following the same rules as variable names. So this is the class. The class name goes here. This is the syntax or structure for writing a class. We end with a semicolon after closing the brace. You end with a semicolon. So this is an example code for class definition. You can see my class, my record here, public, int my age, and string my name. So here we have created a class called my record. The public keyword, this public keyword is called an access specifier. It means that the attribute my age over here and my name here can be accessed outside the class. And inside the class, we have two attributes, which is the my age and my name. My age is an integer that stores someone's age or the person's age, and my name is also a string that stores someone's name. It's like creating a template for a record that can hold a person's age and name. We have class definitions. Now that we have attributes, let's add some functionality methods. Methods are simply a function that belongs to a class. They belongs to a class, and we have two ways to define method. You have the inside class definitions and outside class definitions. So for the inside class code, you need your class, my class name, which is the my record public void get age. This is the inside class code, example for the inside class code. We also have the class method, which is the outside code for the outside. Now you can see it's almost the same thing, but see there's the two colon here, the two colon here. It's an operator. This is called the scope resolution operator. It tells the compiler, these two columns here, tells the compiler that get age belongs to my record class. This get age belongs to my record class. That's what these two columns here does. We also have record parameters, just like regular function. Class method can accept parameters. So, like I said earlier, that parameters act as a placeholder for the data to be accessed by a function. In cases, method can be provided parameters for arguments to be base accepted when calling methods. Here is the example code for a parameter in class modes. You write your class and your my record, which is the type, your public void get class and a string name. So let's go to constructors. So with the constructor is a special method that runs automatically when you create an object from a class. It's like an initialization function. And we have some rules guarding the class constructor. These are the rules. The constructor has the same name as the class. It has no return type, not even void. And it's usually declared as public. It runs automatically when an object is created. The example code for the class constructor. This example code for my constructor. This is one argument constructor. Can also create constructors with two parameters. So what are destructors? Just as constructors create objects, destructors clean up when objects are destroyed. A destructor is called automatically when an object goes out of scope or is explicitly deleted. There are example code of the destructor. So my class, my record, public, this sign over here, my record, destructor, C as location. Notice this sign over here, this sign before the class name. That's how you identify a destructor. Without this, then it's not a destructor, it's a constructor. So the moment you see this sign over here, then you know that it's a destructor. So access class access specifier. Access specifiers controls who can access the members of your class. And there are three types. You have the public, the private, and the protected. So with the public, right, members declared as public can be accessed from anywhere inside the class, outside the class, from other classes. That's what the public does. Members of the public can be accessed anywhere inside the class, outside the class, and even other classes. So this is how we write this example. So class, my record, the member, and int my age. So also have the private access specifiers. For the private, the the members declared as private can only be accessed from within the same class. This is the default access level. So when they are private, it can only be accessed within the same class. Within the same class. So class, my record, public, int my age, private, string name. Can be accessed within the same class. So you have another one called the protected class access specifier. So members declared as protected can be accessed within the class by child classes. We will learn about that in inheritance later. When we get there, we talk about that more. And there's the syntax for writing a protected class. We also have class called a dis pointer. The dis pointer is a special pointer that points to the current object. It's useful when you need to refer the object itself. This pointer, this is the example code for this pointer. My class, my record, public, int my age, in get line returns this. Let's go to objects. Creating and using objects. So an object is an instance of a class created from a class. To create an object of a class, specify the class name followed by the object name. So this is the syntax for writing the class name and object name. So example is the class name is my record and the object name is Jemima over here. That's how we write object class. We also have multiple objects. With a multiple objects, you can create it from a class. Class provides the blueprint for creating the multiple objects, and this is the syntax. My record Jemima, my record Julia. So you can see it is multiple because it's two. Jemima is one, and Julia 2 is another one. You have accessing members. You can use the dot operator to access public members of an object. And the syntax for accessing the object.member, my record Jemima, dot get age, Jemima dot get name. So this one will get the age, the value stored for age, and this one will get the value stored for get name. So I have modifying class members. So you can Modify public attribute directly using the assignment operator syntax. So my record Jemima dot my age equal to 34. So it's like modify just straight away. Then Jemima dot my age, we assign a value to 34 to it using the assignment operator, which is the equal to over there. We also have another class members called the static. So the static members belong to the class itself, not to any specific object. You can access them without creating an object. So both attributes and method can be static members. In this example, declaring of static members. Class my record public static string date of birth. So string my record, the two columns, my date of birth, my day of birth equal to Monday. This is what the static means. We also have object-oriented programming. So classes are foundation of object-oriented programming, which is the OOP. They help us implement three key concepts. That's the encapsulation. So encapsulation means building data and method together and controlling access to them. We use private members and public methods to achieve this. So have the inheritance. Inheritance allow one class to inherit properties and method from other class. We also have polymorphism. With polymorphism, it means many forms. The same method can behave differently in different classes. That's a So the inheritance also allows one class to reuse attributes and method from another class. It helps to write cleaner and more efficient code. Now the derived class, which is the child. The class that inherits from another class, which is the parent, and the base class, which is the parent. The class being inherited from by the derived class. So today we've covered what classes and why they are important, how to define classes and attributes and methods, and constructors and destructors, accessing specifier, which is the public, private, and etiquette, and the this pointer, creating and using object and static members, and introduction to OOP concept. Now classes are building blocks of object-oriented programming. They help you organize your code, make it usable, and model real-world entities in your programs. Next week, the following video, we will dive